Welcome to lab exercise number 4, switches and 7-segment display. In this session, we will delve into the fundamental concepts and practical applications of switches and 7-segment displays in digital electronics. In this lab exercise, our objectives are to understand and apply the following concepts: the use of current limiting resistors and pull-down resistors, the technique of switch debouncing, and the differences between active low and active high outputs. Additionally, we'll explore 7-segment displays, including both common anode and common cathode configurations. Finally, we will write Arduino programs to read push-button switches and control 7-segment displays. Let's get started. You will need the following materials: a breadboard with an Arduino Uno, an adapter that converts 120 volts AC to 12 V DC with a current rating of 1000 mA, 7 220 ohm resistors and 7 10 k ohm resistors, a common anode 7-segment display such as the GNS 3011 or a similar model, and a momentary push-button switch like the BTS1102B2 or a similar type. Introduction. In this lab, we will construct and test Circuit 1 using programs written for the Arduino Uno. This exercise will help us understand the practical application of switches and 7-segment displays in a real-world scenario. Program 1. Our first task is to write a C++ program for the Arduino Uno. Ensure you include an initial block of comments at the start and additional comments throughout the code for clarity. Compile the program before coming to the lab and correct any errors that may occur.
This program demonstrates a simple counter. When I push the button, the counter works and increments by 1, then returns to 0.
Next, we will do Program 2, a switch-controlled up-down counter. Connect a toggle switch and a 7-segment display to the Arduino Uno board. Write a program to control the counter such that when the switch is on, the counter increments from 0 to 9, and when the switch is off, it decrements from 9 to 0. Implement a 0.75-second delay for each count interval. Run the program to verify its functionality, demonstrating the proper operation to your instructor.
This program uses a toggle switch to switch from counting up or counting down. When I flick the switch, the counter counts down.
In Program 3, we will create a presettable up-down counter. Connect a toggle switch, a 3-switch dip switch, and a 7-segment display to the Arduino Uno board. Write a program that prompts the user to enter a predefined number from which to start counting, and use the toggle switch input to determine whether to count up or down. The program should allow for interactive switching between counting up and down using the toggle switch, with a 0.75-second delay per count transition.
This program demonstrates the up or down counter with the starting point coming from the user. Here, the user pushes button, and the counter increments from 0 to 9. Now, flicking the first switch causes the counter to count up, minding that the user starts from 0. Flicking it down causes the counter to stop at the current number. Flicking the second switch causes the counter to count down at the current number.
In Program 4, we will create a traffic light circuit with a 7-segment down counter. Connect 3 LEDs, green, yellow, and red, each with a 220 ohm resistor to the digital output pins of your choice on the Arduino Uno board. Write a program to simulate a traffic light where the green LED is on for 9 seconds, the yellow LED is on for 1 second, and the red LED is on for 8 seconds. Ensure the timing is synchronized with the down counter. The traffic light should operate in this cycle indefinitely.
This program demonstrates the traffic light effect. For 9 seconds, the green LED lights up, next for 1 second, the yellow LED lights up, then for 8 seconds, the red LED lights up. The seconds remaining is demonstrated by the 7-segment display.
For Program 5, you will design your own application involving a switch and a 7-segment display. Construct the test circuit on your Arduino Uno board according to your design. Run the program to ensure it functions correctly, and demonstrate its proper operation to your instructor.
This is a customized program for 7-segment display. When I press the right button, it counts up. When I press the left button, it counts down.
For the last one, Program 6, you will design an advanced application using switches and 7-segment displays. Construct the test circuit on your Arduino Uno board with the following components: 2 light-dependent resistors, LDRs, and 2 7-segment displays, or a dual display if available. Write a program to create a marquee effect displaying 2 different messages. When LDR1 is enabled, the display should show "Hello" scrolling from left to right. If LDR1 is not enabled, it should display "Bye" scrolling from right to left. Run the program to ensure it works correctly and demonstrate its proper operation to your instructor.
Currently, the LDR1 or hello is seen because it detects light. Now the LDR2 or bye is seen because it detects light.
This concludes our video. Thank you very much for your attention and participation. If you have any questions or need further clarification, please feel free to ask. Have a great day.